Okay, so here's y, and they want you to find y prime. This is exercise 12. And so I'm going to make my little pair of columns, let and then. And the place to start is with this 2x. That's the simplest function to start with of x. And so we're going to let p equal 2x. Then dp dx equals 2. So far, so good. Now we're going to rewrite our equation just so we don't get mixed up. Y now equals arcsine of p squared. So the function we want to work on now is arcsine of p. So we're going to let q equal arcsine of p. It's going to be q. And I had to look this up, as you might imagine. I don't know what the derivative of arcsine of p is, but dq dp, it turns out that that is 1 over the square root of 1 minus p squared. Okay, good to know. I'm not going to memorize that, but good to know. I hope if you get that on a test, they don't expect you to memorize that. But anyway, okay. So now we have q and dq dp. So we're making good progress. We go back and we substitute q into the equation. So now it's just simply q squared. Well, that's easy. Now we can just do dy dq equals 2q. And of course we want y prime, which means what we want is dy dx. Do everything in terms of x. But our algorithm tells us to start with dy dq, multiply it by dq dp, and multiply that by dp dx. And so now we just plug in dy dq, that's 2q, dq dp. I'm going to write this a different way. I'm going to write it as 1 minus p squared to the negative 1. Oh, excuse me, negative 1/2. Yeah, negative 1/2. Phew. And then dp dx is simply 2. All right, so simplifying, we can multiply this 2 by this 2, so we're going to have 4q. What's q? Q is the arcsine of p. But wait a minute, what's p? Well, p is just 2x. So that's easy. And that is dq dp in terms of x. And then we multiply that by dp dx. So we already did that. That's 2. So are we done? Oh, no, sorry. We still need to multiply in dq dp. dq dp is 1 minus p squared, and p is 2x, so this is 1 minus 4x squared to the negative 1/2. Now we're done. So you can see, yeah, even when you follow the algorithm, it's not too hard to get a little bit confused. But if you go back, this does make it at least very easy to check your work. You just go, oh yeah, what was dy dq? That's just 2q. What's 2q? It's 2 times the arcsine of 2x. What's dq dp? It's 1 minus p squared, all to the negative 1/2. But what's p squared? Oh yeah, that's just 4x squared. It's just a nice systematic way of doing a complex derivative.